Okay, let's take one more set of examples right here for simplifying algebraic expressions. This time let's use our distributive property. Distributive property says that if we take a constant or a variable, doesn't matter which, multiply it by both terms inside of the parentheses, a sum or difference, then we distribute the multiplication over the addition or subtraction. So let's take a look at a few examples right here, just very straightforward. It says, let's take a look at multiplying 4 times the quantity 3 minus 9x. Well, this is, in fact, an addition in here, even though it comes out as a subtraction when we write it, because we can think of this distributive property right here as 4 times 3 plus negative 9x. So it is important to remember that subtraction is nothing more than the addition of a negative, and when we distribute, that means we're going to take the number in front of the parentheses and distribute it to both terms individually inside of the parentheses. So we're going to be taking 4 times 3, which is 12, plus 4 times negative 9. Well, we know 4 times 9 is 36, so this is going to be negative 36x. And it doesn't have to be 4 times 9 and 4 times x. It's just 4 times negative 9x, and that becomes negative 36x. Of course, the addition of negative is subtraction, so we get 12 minus 36x as the result. Well, let's look at this next one here in B. How is this the distributive property? Well, in fact, that negative in front, when we don't see a number after it, we assume it's a 1. So think of this as being negative 1 times whatever's in the parentheses. And since it is 2 negative numbers this time, we can think of negative 6d added to negative 7. And carry out our multiplication of negative 1 by both terms in the parentheses. So negative 1 times negative 6 is going to become positive 6d. And then, of course, negative 1 times negative 7 becomes positive 7. And so this is our simplified result. It doesn't matter which side of the parentheses our multiplier is on. We distribute the same either way. 8 would be multiplied by 7, and 8 would also be multiplied by 6. Well, 8 times 6, that gives us 48. And 8 times 7, 8 more than 48 is 56. Y as our simplified result. And it doesn't matter whether we have 2 or more terms. We can extend this distributive property and say that if we have a number multiplied in front of each of the terms in a parenthesis, we distribute to all of the terms one by one. So negative 5 would be multiplied by a squared, negative 5 times 8a, and negative 5 times 6. So if I write this out, negative 5a squared plus, I'm going to write it this way, negative 5 times 8a plus, I'm going to take negative 5, multiply that by negative 6. Notice that I'm separating out my negatives here, so I have all additions in my terms. I've got negative 5 times a squared plus negative 5 times 8 would be negative 40a plus negative 5 times negative 6 is going to become positive 30. And simplifying one more time to get rid of all symbols of grouping right here, we're going to rewrite this as negative 5a squared. Recognize that the addition of a negative is the same as subtraction. So we're going to subtract 40a plus 30. Okay, so let's put it all together. What could we do with an expression, these two expressions right here? Now we've got parentheses thrown in all over the place. Well, our order of operations says that if we're simplifying any expression, we should try and simplify anything within parentheses first. Well, in this case, we note that C and D do not have any values in common, neither do here, so we can't add or subtract those. So what we're going to have to do is multiplication next, which tells us that negative 6 would have to be multiplied by each term in the parentheses, the first set of parentheses, and something into the next one. Well, let's rewrite this just a little bit. Again, I like replacing subtraction with the addition of a negative. It sometimes makes it a little bit easier to view. So we've got c plus negative d right here in our first set of parentheses. We're subtracting whatever's in the parentheses here, so we can treat that as the addition of negative 1 times negative c added to negative 3d. Right? So the subtraction is the same as the addition of a negative. We're going to distribute negative 6 into both terms, so we're going to get negative 6c. Negative 6 times negative d becomes plus 6d. Next, we're going to add negative 1 times negative c. That becomes positive 1c. And negative 1 times negative 3d becomes plus 3d. And now we can combine our like terms. We note that negative 6c plus 1c is going to give us negative 5 times c. Those are our two like terms with c. Plus 6 plus 3 becomes plus 9 times d, which is our simplified expression. All right, but what do we do with this monster down here? Well, it's not as bad as you think. Make sure, though, if you have parentheses within parentheses, that you always work from the inside out. So work inside, that should be an S there, sort of, to outside. All right, so right here, 9w minus 4 times the quantity. 3w minus 5 times the quantity, w minus 6. Our first step, I'm going to rewrite everything so that I have all addition. 9w is added to negative 4 times 3w plus negative 5 times w plus 6. Working from the inside out, first we're going to multiply negative 5 into the innermost parentheses. So we're going to get 9w plus negative 4 times 3w minus 5w minus 5 times 6 is 30. The next thing to note is that in the parentheses, whenever we're in a parentheses, right, order of operations has worked within the parentheses, simplify these two like terms that we're combining by addition or subtraction. So this is going to be plus negative 4 times 3w minus 5w is negative 2w minus 30. Now distribute our negative 4 into both terms in the brackets. And we're going to get 9w plus negative 4 times negative 2 is positive 8w. Negative 4 times negative 30 is going to become plus 120. And then when we add our like terms, we get 17w plus 120. And we're done. Happy simplifying.